Hello, my name is Edgar Ochoa. In this video, I'll be going over how to create LDTs in the planet. We will be following these steps to create an LDT for the planet. Step 1, click on Configuration and select the planet. Step 2, open the proper DXF file. Step 3, figuring out the appropriate orientation of the part. If it's the first time choosing the DXF, click on the Define button to set the correct orientation. If the orientation is already correct, or once the orientation is correct, identify which is the top, bottom, or right or left side. Step 4, create the X or Y reference guides as needed. Step 5, select the type of machining to create the LDT. In this video, we will be creating 3 different LDTs. One relative LDT, the example will be a hole, and then we will be creating 2 different absolute LDTs. One with the blade and the other one with the mill bit, which will be a chicken head notch. For example 1, we will be creating a relative LDT. The first step will be to set the couplers to the correct machine. So we will go to Configuration and select the planet. Then we will load the correct DXF file. So we go here to DXF profile, select the correct system, which for this example will be 3075. And then we'll be using 3175 as our part. Since we will be creating a relative LDT, we do not need to establish the orientation of the part, since the takeoff program will drive our location of the hole. The first step will be to select our X and Y reference guides. To do that, we will go to Machinings, and we will start with the X reference guide. Since this is a relative LDT, we will select Not Positioned Reference. Our reference name will be X underscore position, and we will set our default position to 0. Next, we will create the Y reference guide. Now, this is how the Y reference guide is currently shown. However, we will need to change this. The reason being is that the takeoff program reads from the back of the part to the glass pocket. Therefore, we'll need to change the orientation of the Y reference guide. To do this, we will go into these options here. If we first select this option, we can see that this is what we want in terms of the orientation. So then we select our starting point, which will be this back corner. Now, as mentioned, the program reads from back of the part to the glass pocket, meaning that this number will be negative. So to make sure this is in the correct spot, we can test this out by going here and putting negative 0.5. And as you can see here, when we put a negative number, the Y reference guide moves up. So this is an indication that the side that we picked is not the correct one. So we can set this back to 0. Now, if we choose from this side, and again, we select negative 0.5, we can see now that when we do that number, it goes down, which is what we want. Now, since this is a relative LDT, we need to select Not Positioned Reference. Our reference name will be Y underscore position, and the default position will be set to 0. We have now successfully set up our X and Y reference guides. The next step will be to create the machinings for our LDT. First, we can select the side that we want the machining to come from. For the example, be this face. Next, we'll go to the hole option. For this example, the diameter will be 0.188 inches. So we can select next. Now here, you can see all the tools that can be used to create a hole with the diameter that we chose. For this example, we'll be using M188. Now, when we see an L, it means that the tool will have an extender. An extender is used when we want to make sure that the tool does not hit the part. For this example, since we're coming in from this side, there won't be nothing that the machine can hit, so we can select the one without the extender. Select next. Now here, we will tie our machining to the X and Y reference guides that we made earlier. To do this, we just click on each X reference guide. We select here. Then we select our Y reference guide. Yes. And this moves our hole to the intersection of the two reference guides, which is what we want. This will then read the numbers that we put in the takeoff program, and then it will be moved to the correct location. Then press next. Now here we want to leave these to our standard numbers, which for the start will be 0.06 inches, the end will be minus 0.4 inches, and the release 0.5 inches. So now we can select finish. And this has been how to make a relative LDT in the plan. For example 2, we'll be creating an absolute LDT using the blade. We'll be creating this 1 1/4 or 1 5/16 notch on the left side. First step, making sure the configuration is set to the planet. Then we select the correct DXF profile. Now, since this is an absolute LDT, we will need to know the correct orientation of the part. One way of knowing the correct orientation is to open up the CAD. In the CAD, we will set up the part to be the correct orientation based on the campus. This is how the part comes in on campus. And here we are matching the orientation. So then we can do PDF orbit. And we can see that this would be our left side and this side would be our right side. So in campus, this is our left side and this is our right side. We'll be working on the left side for this example. The next step will be to create our X and Y reference guides. For this example, we will have two different reference guides. In the X direction, we'll do one at 1 1/4 inch, and for our Y, it will be 1 5/16 inch. We will start with the X reference guide. We'll go to machinings, select the X reference. Here, since this is an absolute LDT, we'll be using position reference. Now, for our X, we'll do 1.25 inches. And select next. Now we will select our Y reference guide. Now we want our starting point to be this back corner here. This corner. And then, as mentioned before, our Y will be 1.3125. Again. And now we have successfully created the two X and Y reference guides. The next step will be to create the machinings for our LDT. We go back to our fab ticket. We can see that we will be creating two different cuts. One for the 1" and a quarter, and the second for 1" 5/16. We will be setting priority, which means the order of the machinings. The first machining we want to do is 1" and a quarter, and the second will be this 1" and 5/16. And going back to Campus, we will select the blade option. Now we will select the width as 5.25, the height as 1.5, and then the tolerance we leave as is. Now, the reason the width is 5.25 is because that is the width of our part. If this is measured, it comes out to 5.25. And the height is 1.5, which we want to be a bit bigger than the length of our cut, which is 1 and a quarter. Now, the next step is to select the reference vertex. For this example, we'll be selecting 2. The rotation would be 90 degrees, and our figure versus will be default. For a further explanation of how properly fill out this pop-up, please see the video named How to Use the Blade Tool. Click Next. Now here we select the blade that we're going to use, and for this example we will select after separation cuts. This option is selected when we are working with the blade or the machining is on the ends of the part. Next. Now here we will change the orientation or location of the blade tool to come in from this side. If we click back and select Next, now we can see the profile of our machining. So the next step will be to tie this machining to the X and Y reference guides that we have created. So then we select our X reference guide and then select our Y reference guide. Now our machining has been tied to both X and Y reference guide at the intersection point. And here we can see that the machining does not pass the 1" and a quarter or the 1" and 5/16. Now, if we go back, we want this machining to be the first machining that is done. So we will set our priority. To do this, here in the set, we will select 1, and the priority will be 1. Next. Select Next. Leave these options as is. Select Finish. Next, we will create the machining for our second cut, which is the 1" 5/16. We want the machining to come from the back. Next, we select the blade tool. We will leave the width and height the same. The reference vertex for this cut be 3. the orientation will be 90, and this will be set to default. Select next. With our tool. Now we can set our priority. We want this to be the same set as before, but the priority will be 2. So that this machine that we create goes after the previous machine. We will also select this after separation cuts option, since we're using the blade, and we are also at the end of the part. Next. I can go back, select next so that we can see the profile. Now, the same as before, we will tie our machining to the X and Y reference guide. Select the X guide and then the Y guide. And as you can see, we are within the perimeters of our X and Y reference guide. We select the face. We can see that we are cutting all the necessary material. The next step will be to select next. Leave this at our standards and select finish. Now, what we can do is go to this piece tab and run a simulation to see how the cuts will be. We are expecting to see this as our first cut and then this back side as our second cut. So we can run the simulation. And we can see that the machine will run per the priority that we set. Now, this has been the second example on how to create an LDT on the plant. For example 3, we will be creating this 2 3/16 wind load notch on W75 5263. First step will be to open up Cam Plus and make sure the configuration is set to Planet. Then we will open up the appropriate DXF file. The system is W75 5263. Now that we have the DXF file, the next step is to figure out which side is the top and which side is the bottom. To do this, we will open up our CAD, go to model space, orientate this part to be exactly as it is in Cam Plus. As you see here, the orientation matches our Cam Plus. Now, if we rotate the part, you can see that the top is on the left and the bottom is on the right. So in Cam Plus, this is our top and this is our bottom. Now that we know that this is our bottom, we can start creating our X reference lines. You see here on our PDF that we will need 2 X reference lines, one at 2 3/16 inches and the other one at 7/16 inches. So now we can go back to our canvas, go to machining, select X reference line. So our bottom is on this side and our X reference line starts here. So in order for us to start from the other side, we would do max minus 375. And this moves it to the other side. Now for our second X reference line, do the same thing, again using max minus 2.1875. And now we have created two X reference lines. Next, we will create our Y reference lines. Go to our PDF, we can see that our first Y reference line will be 7/16 from this corner. So go back to Canvas, rotate our part, select Y reference. We want the machine to come from the right side. Then our next step will be to put our starting point this back corner right here. Then we will do minus 0.4375 to 7/16. End. Now our second Y reference line will be 7/16 plus 3/8, which is 13/16. So I'll go to our Y reference line. Make sure we come from the right side. Select the same endpoint as before. This time we'll do minus 0.8125. Now we have two Y reference lines. Our next Y reference line will be 2 5/8 from this back corner. We go back to Canvas, Y reference line. Make sure we come from the right side. Pick the same bottom corner. This time will be minus 2.625. Our last Y reference line will be 2 5/8 plus 5/8 from this corner, which is 3 1/4. Back to Y reference line. So we come from the right side. Pick the same starting point. And then minus 3 1/4. So now we have completed the main Y next reference lines. Now that we have created the 6 main reference guides, we need to add one additional reference guide. This reference guide will represent the end of the part after the separation cut. The reference guide will be 0.125 from the end of the part. We will go to our X reference, and for this example, it will be max plus 0.125. Now, the edge of our blade will now go past the material after the separation cuts, which is represented by this additional X reference guide. Now that we have created all the X and Y reference lines that we will need, we can begin creating our LDT. So we go back to our PDF, we will create this slot right here, which is 5/8 by 2 and 3/16. Back to Canvas, we will use a rectangle. Here we put our width and height of our rectangle. So our width is 0.625, which is 5/8, but we would like to add a bit of a tolerance. So we would set it at 0.644 inches. Our height is 2 3/16, but we will add that additional 1/8 that we added for our limitation, which will make it 2.3125 inches. Our radius will be 0.125 inches, and this is set at 180 degrees, meaning the slot will come in this direction. If it was set to 90, it will come in this direction. So I click next. This table shows us all the tools that can create the rectangle with the dimensions that we set. For this example, we will be using this M250 tool. So then we can click on next. And here we can select our X and Y reference lines. We will first tie it to this Y reference line. The reason being we do not want the notch to exceed this wall here. So then now we select this X reference line, which is the 2 3/16. And we gotta make sure that the machine comes from the right. So now if we look at it from this view, we want to move the machine down. In order to do this, we'll select this width and divide by 2. Now the width, which we said earlier, is 0.644 inches. So we'll divide that by 2, which is 0.322. Now here in our H, we'll do minus 0.322 inches. And you can see the machine is moved down. Now we can see that it does not go past this wall. And the tolerance that we added is what's being left past this line. So now we go to the side view. We want this profile to land between this X reference line, which is the 2.3125, and this, which is our limit. So to do that, we'll divide 2.3125 by 2, which gives us 1.15625. So here in our X, we will do 1.15625. As you can see, the profile lands perfectly between the two X reference lines. So then click next. Now these are our standard numbers, which is what we want. We can confirm 0.06 inches, minus 0.4 inches, and 0.5 inches. So now we click finish. Now we can move on to create the second part of our LDT, which will be this here. Now this we'll be creating using 2 different slots. One to take care of this 7/16 height, and the other one to take care of the 2 3/16 height. Back to our campus. Here we can rotate our part again. And go to our slot option right here. We'll select our width and height. So for the first slot, we'll do 0.25 inches. And then our height will be 0.5625, which is 7/16 plus 1/8. Again, we'll keep this at 180. For our tool, we will again select this M250 tool and select next. Now again, we make sure we come in from the right side. And now we hit select our appropriate X and Y reference lines. So for our X, we'll select this 7/16. And for our Y, we'll select this one here. And just have to locate it accordingly. Go to the front view. We want this to be aligned. So we'll do the width divided by 2. In this case, will be 0.25 divided by 2, which is minus 0.135. So now we go to the side view. We want our machine to be in between this X reference line, 7/16, and our limit X reference line. So in order to do that, we will divide 0.5625 divided by 2 inches, which gives us 0.2825. So go here to our X, put 28125. So you can see now our profile is between the two X reference lines. And next. Make sure this is back to our standard numbers, which it is. Select finish. Now we can create the last part of the LDT. So for the next part, go back to PDF, creating the 216 size slot. So we will go back to campus and select the slot option. So now we can set our width and height. For our width, we'll do 0.188 inches, and the height will be 2.3125. Again, here we can see all the tools that can create our slot. So for this example, we will select M188 and select next. Make sure we can put the right side. And now we can select our X and Y reference lines. So we'll select 216 reference line. And then we will select this 7/16 X reference line. Now we can just move our profile accordingly. We go to the front view. We want to move the profile up. So we will do the width divided by 2, which will be 188 divided by 2, which is 0.094. And now you can see we're taking care of this entire width with these two different slots. So I'm going to go back to the side view. So now we want to make sure that the profile is between this X reference line and our limit X reference line, which would be dividing the height by 2. So that would be 2.3125 divided by 2, which is 1.15625. Now we have our profile between the two X reference lines, which takes care of the small slot and then a bigger slot. Go next. Make sure this is again set to our standards. 0.06 minus 0.4 minus 0.5. Finish. And now we have successfully created this absolute LDT.